Welcome back, and you know what? We finally made it. This is our beginning of our section on real world example. And this particular lecture, we're going to tackle triggers. I'm going to start out real simple with our triggers in that triggers should remain simple. When they get too complex, they mutate, and that's something we'll talk about in the next lecture. But for now, we're going to take a look at a trigger which responds to the insertion of a new row into the users table. Backing up just a little bit, generalization. Triggers are familiar to all of us as coders now because they fire in response to events in the database environment. An event might be a DDL, data definition language command, being executed wherein a new user is created, a table is created, an index is created, something is altered, something like that, but more commonly used in association with DML or data manipulation commands. That is, I inserted a row, I updated a row, I deleted a row. We are going to take a look at a trigger which responds to inserts to our users table. In particular, we're going to check that some business logic is being upheld, assign a unique primary index, and then pass the new row onto Oracle for insertion. Should be great fun. All right, time to open your Lecture 7 script and SQL Developer. Let's start taking a look at some trigger code. Cool.
Up to this point, we've built mostly anonymous PLSQL blocks. That is, these little snippets of code were not named and they did not become part of the permanent database schema. We were just using these little snippets to demonstrate a point or learning objective and did not intend for them to be permanent. Fine, but now it's time to start creating named code blocks which become part of the permanent ongoing set of schema objects. We begin with the simplest type of named block, a trigger. This is the prototype syntax for a trigger creation statement. Keyword create, optional, yet always included keywords or replace, keyword trigger, and then the trigger name. Next comes one of two keywords either before or after. That is, will this trigger code execute before the associated DML command or after its completion? For me, 95% of the time it's going to be before an insert or delete. Only real time I use after triggers is with auditing. Who made a change to the database? When was the change made? And what were the previous values? Why not use Oracle's built-in auditing capabilities, you say? Because they are generally too aggressive and kill performance. Better to shut those guys off and just audit those real important tables, for example, finance, user security, that sort of thing. Okay, moving on in our syntax, we see that we can fire our trigger on the insert, update, or delete of an entire row, or on the update of just specific columns within that row. To have it, your trigger fire on more than one of these options, just logically combine them with the OR keyword. All right. Moving down our syntax prototype to the optional for each row clause. This guy behaves just as the syntax suggests. Add this clause and insert 50 rows to the table. The trigger code will execute 50 times, once for each row. Leave this clause out and the trigger will fire only once when those 50 rows are inserted. Next optional clause is a when logical expression. When the logical expression evaluates to true, the trigger fires. The logical is false, the trigger doesn't. This is actually pretty cool stuff, because I've seen instances where the business logic being tested by a trigger actually lives right here. If the business requirement is not met, all the trigger does is throw an error. For example, what if the business rule was credit card transactions have to meet some minimum value? Fine, test it right here, and if not met, have the trigger throw an error. Just else let it pass straight through. Simple one-liner. Finally, we throw in our declaration and execution blocks, and we have a functioning trigger. Cool. Now it's time to look at a real-world example. Okay, here's the code for our very first real-world trigger. Pretty simple, but also very common usage. We begin with our standard create or replace trigger keywords and then add our trigger name. Standard convention here is just as shown. This is an insert trigger on the users table. This trigger is going to fire before the actual record insert is going to fire for each row inserted. Please note how I have also associated the trigger name with the end keyword. As we get progressively more complicated examples, there's going to be instances where we want to nest procedures. This convention helps us to clarify with which procedure a specific end keyword is associated. Now, if you haven't already done so, please go ahead and copy and paste the calc password strength function into developer and compile that guy so we can reference it here in our trigger. We'll examine this function in detail in lecture 11. For now, let's just know that the calc password strength function takes a password input parameter and returns an integer in the range of 0 to 100, describing the relative strength of that password. 100 being a very strong password and 0 being flat out unacceptable. Okay, given that background information, we should now be able to walk through and better understand the top paragraph of code in the body of our trigger. If calc password strength left paren :new.password equals 0, then, well, looks like we're passing something called new.password to the calc password strength function and then checking whether that return value is equal to 0. What's the magic? Insert triggers have a pseudo row called new, and you reference that guy with the colon notation shown here. Columns within that row are referenced using dot notation. Update triggers have two pseudo rows, new and old. Same usage. Delete triggers just have the old pseudo row. Anyway, you need to check the values of columns being inserted to a table before actually allowing the insert check. Use the :new pseudo row dot column values. Here we're enforcing password strength requirements, so we pass our candidate password into the calc password strength function and then evaluate its relative strength to determine how to proceed. Given the code, our business rule apparently requires us to throw an error if the password strength comes back 0. Suspend login for a year if the password is weak, thus forcing the user to change it before using the system. Or finally, if the password is finally, simply set the start date to now and move on down the code. The next paragraph of code is equally straightforward. If you'll recall, when we defined our schema, we created a sequence named users_sequence. A sequence is nothing more than a counter object. In our case, here we told the schema we wanted a counter object named userSequence. Start counting with 10 and add 1 each time you count. Don't save any upcoming values in the cache and never start counting again from its initial value. So what are we doing in this line of code? Sure, we're going out to that sequence and asking for its next value and then assigning that value to the user ID of our new pseudo row. Remember, dual is that table owned by sys with only a single row, so we select functions against that guy. Easy enough. We conclude our trigger body code with a debugging error handler, which we would of course change to a more end-user friendly message should this code ever go into production. All right, so if we're following along in Developer, now's the time to compile our trigger so we can test that bad boy. Now, you can actually compile triggers for debug, but it's kind of clumsy, so I generally just test them by writing the associated DML. We begin here by checking the password strength of this Rick is cool password. Well, obviously this is not only a falsehood, but also a very bad password. As such, our calc password strength function returns a relative strength value of 0. If you will check back to our trigger code, this password should result in an error message for any end user row with this password. Ta-da! As you can see in this slide, when we try to insert a row to the users table including this password, our trigger throws the appropriate error message back to the user. Get out of here, you bum, and take your Rick is cool password with you. All right, now we move on to an acceptable but still poor password. My Rick, aren't we being clever? This time our password is better1. We see from this slide that our better1 password result is a relative strength measure of 69. If we go back and again review our code, we see that this insert will now complete, but the effective start date for this new user will be set to 1 year into the future, thus effectively forcing them to upgrade their password. One can only hope that the user interface had a message to that effect, as we obviously didn't inform anybody of our business decision. It's a real-world example, but I didn't say it was a great one. We execute our insert followed by a select and find that our trigger operated properly. Yes, I wrote this code on the 25th of May, 2017. Beautiful sunny day in the mountains of North Carolina, the U.S. Sorry you missed it, guys. Well, I'm pretty sure you can guess where this example goes next. We of course improve our password by best1, which scores a relative strength value of 86. Upper and lowercase characters and embedded symbols with no repeaters or sequences. Nice password. According to our trigger code, this new user should get a start date set to sysdate and thereby become immediately effective. Let's do the insert and then check our results. Ta-da! By the way, did you notice what happened between our two final examples with respect to the user ID? Yes, despite our having executed a rollback associated with the second example, we still incremented the sequence from 11 to 12 between the execution of the second and third tests. Net takeaway: sequences do not roll back. It is assumed these things are always used to generate a false primary key value, and as such, whether these values are perfectly packed, not missing any values, is unimportant. No worries. Now, before we wrap this lecture up, I want to save all of you a mistake made by every new trigger author: recursive trigger calls. Do not include the insert statement in insert triggers, the update statement in update triggers, or the delete statement in delete triggers. Remember, your trigger firing before that event. If you include these statements, you're setting up a recursion cycle. Your first call to the trigger fires a second occurrence of the trigger, and Oracle finally throws your transaction into the trash for running on too long when it gets to some huge number of recursions. Hey, everybody makes that mistake when you first start out with triggers. You owe me one for sparing you that pain and frustration. Okay, before we wrap this lecture up, I want to test our trigger with a multi-row insert. Forgot to do that earlier. Although I know from past experience that this trigger is going to behave just fine with multiple rows, it is always a good idea to test it as such. We won't get into the details here, but in our next lecture, the value of this type of testing becomes very evident. To test an insert trigger with multiple rows, all you need to do is set up an appropriate insert with select statement. Here we're validating our select statement by running a little distinct query against the generic plays table. Why the distinct? Well, if you recall, We put a unique index on our users table made up of the combination of the username and password fields. Pretty standard stuff. Anyway, as you can see, our select statement generates a bunch of rows, all appropriate for insert into the users table. By the way, did you notice the use of the magic number 42? Thanks for the fish. Hey, if you didn't get that little joke, please look it up. Hilarious book. Next, of course, we add the insert component to our select statement and give it a run to see how our trigger performs under a multi-row insert. All right, no errors. That looks encouraging. Let's just run a select star for verification. Perfect. Let's just roll back and call our trigger tested. Remember, however, always test those triggers with a multi-row update. As we'll see in our next lecture, some funky stuff can happen.
All right, I hope that was fun for you and a good introduction to triggers. First named type of code we're starting to study in our first real world example. Now, I know that seems simplistic, but you know what? Triggers are best when the code within them is simplistic. So what did we learn? Well, we started out by taking a look at the prototype syntax for a trigger. Create or replace trigger name. Easy enough. Before or after, insert, update, delete, or update of column list. Optional for each row. Optional when logical expression. Real straightforward stuff, and something, quite frankly, you just got to put to memory. But it's not a bad deal. Not a bad deal at all. If you will recall, we then took a look at the body of our trigger, wherein we first imposed a little bit of business logic that enforced a password strength criterion. In particular, if a password didn't meet a particular strength criterion, I think it was a value of 50 or something like that, we rejected the insert completely, just threw an error back at the user. Next, we determined that if the password strength was greater than 50 and less than 70 or something like that, we would go ahead and complete the insertion, but we would not enable the user's username and password such that the start date wasn't set, and as such they couldn't use the system yet. We did nothing more than force them to go out there and correct that password. Finally, if it was above a value of 70, we not only completed the insertion, but we also enabled that user's login. Now, remember how we did that. We'll study the actual calc password strength function a little further down the line, but for right now, we passed it the :new.password syntax. What were we doing there? We were using the new pseudo row referenced by the colon syntax, and then the field within it password via the dot notation. Straightforward stuff. Our final learning objective was to take a look at that sequence and the next val, and using that syntax to assign a primary key value, false primary key, very common stuff. Okay, in our next lecture, we are going to take a deeper look at triggers, and in particular, how when you use them too robustly, you can in fact get in a whole bunch of trouble with them. So that's why we keep the logic inside of triggers relatively simplistic. In the interim, you go out there and you have yourself some fun, but learn something every day. It's what's important.